Find the area of the region enclosed by the curves y equals x squared and y equals x. We definitely want to do a sketch of this just to get an idea of what it's going to look like. We know that y equals x squared is an upward opening parabola whose vertex is at the origin. And we know that y equals x is a diagonal line that goes through the origin as well. And so if we look, this region in between them ends up being a sliver there. In fact, my marker is a little bit too thick to color it in perfectly, but we end up having that. And so we need to find our limits of integration. We can see that the lower limit is going to be 0. That's where they intersect on the left side. And then the right limit is actually going to be 1. We know that both of those go through the point 1, 1. And so to find the area, we're going to have to integrate from 0 to 1. And remember that we have to take the upper curve minus the lower curve. And the upper curve for this region comes from y equals x. So we're going to have x and then minus the other one, x squared dx. And we're good to go. It's a pretty easy integral to do. The integral of x is x squared over 2, and then minus x cubed over 3. We use the power rule on both of those, evaluating at 0 and 1. And we know that when we evaluate those at 0, they're going to be nothing, so we don't even have to do that. If we plug in 1, it's going to give us 1/2 minus 1/3, and of course minus that 0. And 1/2 minus 1/3 is 1/6, so that's the area.